Hello my dear students, how are you all? Welcome back to the channel. So today I am here to explain you, to guide you with all the formulas involved in your chapters that is coming for Mathematics PU2 Unit Test. Okay, so there are 5 chapters. We have relation and function, we have inverse trigonometric function, we have a matrices determinant, and we have the last one is continuity and differentiability. So for all the 5 chapters I am going to explain you all the formulas which is very important to solve the problems. Okay, now if you are somebody who is watching this session for the first time and didn't watch my previous session on the PU2 unit test, go ahead, watch that session. In that I have explained you 84 questions in detail that is going to be sufficient to solve the problems coming your way in unit test. Okay, so let's start the session from the first chapter itself. We have relation and function. We have relations and functions. So in that, you know that questions are coming based like identify whether the given relation is reflexive or not, whether it is symmetric or not, whether it is transitive or not. Okay, so if you see the reflexive relation, basically what is the condition? The condition is very simple as ARA. What is the condition? Condition is very simple as ARA, means if the element is defined unrelated to itself, that has to be reflexive. Of course, it is should be true for all the elements in the given set. Okay, wherever the relation is defined, right? Check here, relation R is defined on the set A. So for that, whatever the elements are there in that set A, for all the elements, every element should be related to itself. That is the reflexive case. And of course, other than that, other elements can come. For example, if I take here 1, 2 is my set A, then this reflexive relation will be given by what? Will be given by 1, 1 and 2, 2, and apart from this even 1, 2 can come, but this has to be the case. You cannot miss out on 1, 1 or 2, 2. Okay, 1, 1, 2, 2 should come. Then apart from that, other elements, other ordered pairs are also allowed, especially in the case of identity relation. That is not true. Okay, in the case of identity relation, only we need 1, 1, 2, 2. In the case of identity relation, only 1, 1, 2, 2 is allowed, but in reflexive, other elements can also be accepted, can be part of the relation. Let's move on to symmetric now. In symmetric, what happens is you have this condition true. So you have ARB, means relation A. So the relation is such a way that A is related to B, and of course B should also be related to A. Both have to be true. ARB is true and BRA is also true. Okay, and for transitive relation, what happens in this case? You have 3 conditions. So you have ARB, BRC and ARC. Again, ARB and BRC are if conditions. So in this you have if conditions. If ARB is true, what is the meaning of ARB? The ordered pair A comma B is true. Okay, and BRC is true. What's the meaning of BRC? The ordered pair B comma C is part of the relation. BRC means the ordered pair B comma C is the part of the relation. Okay, then the then condition is ARC should also be true. ARC should also be true. It means that the ordered pair AC should also be the part of relation. Okay, so this is clear. In this we have ARB, BRA. In this we have 3 conditions. So ARB, BRC and ARC. Okay, got it. So again, if you have all 3 true for any given example, they're asking you if all 3 is valid at the same time, then you can say the given relation is equivalence relation. This is the one of the most asked question even in your finals or boards, or it is in the case of CET as well. So one question can come for sure from this particular definition, whether it is unit test, of course it is coming, or it is going to be your boards or CET. Moving on. So what we have next is functions. In functions we have to deal with in our syllabus 1, 1, on 2, and of course the bijections. Okay, so 1, 1 is called as injective function, on 2 is called as surjective function, and bijective is the combination of 1, 1 and on 2. Okay, sometimes we write the opposite of 1, 1 as not 1, 1, not 1, 1, also as many 1. The opposite means if a relation is not 1, 1, we call that to be many 1. Okay, we call that to be many 1. If a relation given to you, if you identify it as not 1, 1, we call it simply many 1. Okay, and for on 2 we call it to be simply into. We call it to be into relation. So if we have not on 2, that is called as into relation. Just giving you marking so that you understand the opposite case also, because in the examples, no, in the questions MCQs they can say many 1 into. If they are given option like that, many 1 into, but your answer is giving you not 1 1 not onto, then you should know that is the same thing. Many 1 into is same as not 1 1 not onto. Okay, great. Now bijective is the combination of both, as I said. Now how would you identify 1 1 onto function? So there is two approach. One approach is the approach of algebra, okay, or graphs. Another approach is the approach of derivative, basically calculus. So when it comes to the approach of derivative, simply check the derivative of this. If your dy by dx for the given function is either more than 0 or not both or less than 0, then what happens is you can say it is going to be 1 1 function, because the nature of the function is unique. It is either increasing or decreasing. More than 0 means increasing, less than 0 means decreasing. So if it is unique means you can say it is 1 1. If not, if it is not clear, then you can say it is not 1 1. That's the derivative approach. Now for onto, what happens here? In the case of onto, you look for codomain and domain equal, okay? Codomain, sorry, not domain, I mean codomain and range equal. For onto, you look for codomain and range to be equal. Codomain and range should be equal in the case of, range should be equal, are equal, okay, in the case of onto function, in the case of onto function. And other approach is what? Other approach, the algebraic approach is very simple. So if you have, let's say, 2 points x1 x2 or a1 a2, then function value of a1, if it is equal to function value at a2, function value at the point a1, if it is equal to function value at the point a2, then the point also should be equal, means it should be the same point, okay? Means for every one point it should be only one image. For every one value in the domain there should be only one image in the codomain. Okay, I can draw and show it to you. 1 second. Yeah, if you see the mapping, right, this is a domain set, so we will have elements in domain. Let's say we have A, B and C. So for every one of the element in the domain you will have only one image. This is called as 1 1, okay? You can have here 1 2 5 9. So check here B and C. So for every element in the domain set we have only one image in the codomain set, okay? That's your 1 1 part. Now what about onto? Here, can this be onto function? Check here, this is 1 1, that's true. This is 1 1, that's true. What about onto? Not onto, sir. Why not onto? Because check here, the range is 1 to 5. The range is 1 to 5. Right here, the range will become what? 1, 2, 5. This is my range. What about codomain? Codomain is 1 to 5 9. Codomain is your codomain. Your codomain is 1 to 9 5. 1 to 5 9 or 1 to 9 5. Are they equal? They are not equal. That's why it is not onto. That's the way to identify your what do you call onto functions. Now there is other approach to find onto also. Remember I taught you this. If you're looking for, let's say, onto functions, excuse me, let me change the ink color. If you're looking for onto functions, okay, we had other approach also like derivative. What's the approach? Try to put x as plus infinity and your fx should also tend to plus infinity, okay? Same way also, this is and condition, this and this both, x as negative infinity, you should also get f of x as negative infinity. Again, this approach works only in the case of MCQs, okay? The approach that I have given you, this approach and this approach, only true for, only used for MCQs, okay? Only use this approach for MCQs. Otherwise, use the approach of algebra. Use the approach of algebra. This is clear, I guess, okay? This approach is for only MCQs. There is a separation over here. The derivative approach to find the 1 1 is for MCQs. Same way, the infinity approach is to find onto function, again for MCQs. Otherwise, you have to use that, find the range and codomain, check whether they are equal or not, and that's how it is, okay? Please check. And if you get both true, you say the function is bijective, and then it can also be called as invertible function, okay? It means if you have both cases true, the function becomes bijective, and then the function can be invertible. It has a inverse function, means the function inverse exists, alright? So please take a screenshot of this, because in the formula that I am going to give you the sheet, I will not give you these many markings. This is just to explain you. In the formula sheet you will have just the sheet given to you, not the markings, okay? Moving on. Now inverse of the function. How do you find inverse? So first of all, you have to identify whether the given function to you is invertible or not. Okay, whether the given function is invertible or not, and that you identify using bijective. If the function is given as bijective, it means it is going to be invertible. Okay, so see this, how do you find bijective? Basically, check for 1 1 and onto. You can use the algebraic approach, f of x1 equals to f of x2, or draw the graph of the function if you can. Let's say the function is like this. If you draw a straight line parallel to x-axis, cutting at only one point means 1 1. Okay, the another way to find 1 1 function. Identify that if it is bijective means you can look for inverse. Inverse happens what? Inverse will be basically a function where it will be defined in a in the reverse way of domain and range. Check here, the function f is defined from a to b. A is the domain, B is the codomain, but inverse will be defined like this. B will be your domain and A will become your codomain. Okay, and this will be justified. F inverse of f will become simply equals to x. Remember, we have seen the examples like this. Cos inverse of cos x. What's the answer? Simply x, because cos inverse and cos are inverse functions of each other, so that's why they cancel the effect. Okay, cos inverse of cos is simply x. Same way, f inverse of f is simply x for all x belongs to the A. All x belongs to the A, the domain of the function f. Now if you might be thinking, sir, domain over here is B. Don't think like that, because check here, what is the x over here? X is in the function f. For the function f, x belongs to what? The set A, the codomain, sorry, the domain. That's why I've written here x belongs to A. Okay, same goes for y also if I'm writing in terms of the variable y. Okay, now composite function, you're writing fog or gof. Okay, so you have to find the function fx, whatever it is given to you, and replace the variable x in g, replace the variable x in g by fx. If you do that, you'll get the composite of gof. You can also do for the fog as well. For fog, what is going to happen? In the function f, replace x by gx. In the function f, replace x by gx. That's the case of fog. I hope this is clear. Okay, so can I remove the markings now? Let me remove the markings over here. So I hope all of this is clear. Moving on, number of relations. Again, this is very, very important. Very, very, very important. You have questions coming like this for sure. Okay, especially in the 1 marker category. Number of relations from the set A, which is given as, the cardinal number is given as m, and the cardinal number size means what? Size means cardinal number. Okay, size means cardinal number. Basically what it means is number of element in that set. So that is given as n and this is given as m. So how do you find that? 2 power m cross n, 2 power m into n. Okay, number of functions from A to B is given by n power m. Okay, number of injective function is given by simply this npm, npm, and number of bijection is going to be given by n factorial. This you can ignore because you have not learned. This is not part of the syllabus. This question, the use of Stirling function is not part of the syllabus. This is called as Stirling number. Not there for you right now, but sir, you might think, so number of surjection question is coming my way. Okay, even though you are saying that Stirling function is not there in our syllabus, but I've seen questions like this where we are supposed to find number of onto function, number of surjections. Then how do you solve that? We have to use bijections. Remember, this is a property. There is a property. If a set is defined from itself, if I am defining a relation, let's say like this, A to A, defined on itself, then what happens is, if A is 1 1, it is onto also, and ulta is also true. If A is onto, then it is 1 1 also. Okay, we use this method. Alright, so if you find as onto, you can use the 1 1 approach, which is a injective approach to find the answer, or basically going to be what? The combination will become bijective. 1 1 onto together, it will become what? It will be bijective. So you can use the formula of bijection clearly. You can use the formula of bijection, that will be enough. Alright, so these formulas are very important. Please download the class notes and revise these formulas. Okay, so this was the end of your chapter relation and function. Now I'm going to move on to what? Move on to your second chapter, which is inverse trigonometric function. Again, I'm starting with the most important part of this chapter. The most important part of this chapter is what? Is your formulas or domain and range. I can't even tell you how much important it is. Okay, whether any question which has any role to play in inverse, will be based upon these properties for sure. You have to have understanding of their domain and range. Without that you can't solve any question. Okay, so inverse of sine is given as like this, sine inverse, domain is -1 to 1, okay, and cos inverse which is -1 to 1. For tan inverse the domain is all real, cot inverse domain is all real again, and the range is also given here, -pi/2 to pi/2 for sine inverse. For cos inverse it is 0 to pi. For tan we have -pi/2 to pi/2. For inverse cot we have again 0 to pi but open. Check here, this is closed. First two are closed, the last two is open, okay. These two are closed, this two is open. And for sec inverse what happens is, from the domain, what's going to happen? In the domain what will happen? You have to remove the -1 and 1, okay. So it's going to be all real for this, all real except for -1 and 1. All real except for -1 and 1. I can write this. For sec inverse, no, it will become all real except for not close bracket, open bracket actually, open brackets, -1 to 1. So to remove this from all real number set, remove all the real numbers between -1 and 1, excluding -1 and 1, okay, means -1 and 1 will be part of the domain of sec inverse and even cosec inverse also. The same domain is there for both of these, all real except for -1 and 1. Got it? That's for sec inverse and cosec inverse. And then this is your range given here. I hope you know that range. Why range, sir? Because output of any ITF is always an angle, okay. Remember, in trigonometric function we put the angle, we get some value out of it, okay. But in the case of ITF we put some values, some real numbers, and we get the result out as angles, usually in radians only, usually in radians, okay. So this is clear. Let's move on now. So next we have basic identities. Next we have some basic identities. When we are using sine inverse of -x, it simply comes out sine inverse of x, okay. For cos inverse it is different story. We have this as pi minus cos inverse of x, pi minus cos inverse of x, okay. And for tan inverse of -x, it will be again minus tan inverse of x. So basically for this and we have cosec, right, these three property remains same, minus sine inverse of x, minus tan inverse of x, and minus cosec inverse of x. But for cos and cot and sec, this is different, pi minus cos inverse, pi minus cot inverse, and pi minus sec inverse. If you have watched my previous session, I have solved questions on these properties, very useful, okay. Almost in every question coming in inverse trigonometric function, this property can be of use. Again, not as many questions on this property, but can be utilized in your CET examination. That's why I have listed it over here also. Sine inverse of A plus cos inverse of A is pi/2. Same goes for tan inverse and cot inverse. Basically your, remember, compound angle relation, compound angles ratios, okay. That is the combination over here. Have a look, sine and cos, tan cot, and sec cosec. Sine cos are complementary, complementary angle, no, not compound angle, complementary angle, complementary ratios, right, complementaries, complementary angle ratios. Sine and cos are complementary, tan and cot are complementary, and sec and cosec are also complementary ratios. So these are the basic identities. Now again, the double angle and half angle identities for inverse function. We also have for simply trigonometric function, but in inverse also it is there. Sometimes it is very useful, okay, especially for challenging questions. If you know the formulas, it becomes a lot of time saving, you end up saving a lot of time. Please check. We have 2 tan inverse in terms of tan inverse, we have 2 sin inverse in terms of sin inverse, we have 2 cos inverse in terms of cos inverse, okay. So this is nothing but 2x upon 1 minus x square. Remember, you write x as tan theta. Here also we have x as sin theta, okay, the 2 sin theta into cos theta, okay. And this is also 2 cos inverse of x in terms of cos inverse, and we have conversion between the inverse function, sin inverse to tan inverse, cos inverse to tan inverse, and tan inverse to sin inverse. Please remember these formulas, they are very important, they are very important, okay. So I am going to give you this class notes of this particular session. Download the PDF and revise these formulas again and again, not once, not twice, but until unless you are thorough with them, okay. You have to prioritize this, very important. For mathematics, formula is a must. If you don't have the formulas, there is no point of writing the examination only, right. So Pythagorean identities are there, the basic that you learnt in grade 10, sin square plus cos square is 1 plus tan square is sec square, 1 plus cot square is cosec square. I understand that this is not part of your syllabus. This chapter is from PU1. Then why I'm giving it to you over here? Because when you come and solve the questions of ITF, of differentiation, of continuity, then this formula plays a big role. That's why I've written over here. Okay. So see, complementary function identities again. Sin 90 minus theta, cos 90 minus theta is sin theta, tan 90 minus theta is cot theta. So basically, whenever you have this value, this angle as multiples of 90, whatever multiple, odd multiple. If you have odd multiple of 90, okay, then what will happen? The sin, cos, tan, whatever the ratio are there, they will change into their complementary counterpart. Sin complementary is what? Cos, cos is sin, tan is cot, and cot is tan. Okay, so if you have over here this angle as odd multiples of 90, means 90, then 270, like that. Okay, so if you have odd multiples of 90, then what will happen? They will change into this ratio will change into complementary counterpart. But if it is with pi, if it is with 180 degrees or pi, then it will remain same. Whatever is the ratio over here will remain same. Okay, and again all of this will follow the quadrant rule. All of this will follow the quadrant rule. Quadrant rule, which is what? Which is like this: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Here we have all 6 ratios positive. In the second one we have only sine and cosec positive. In the third one we have tan and cot positive, and the fourth one we have cos and sec positive. Means the angle where it is lying, think about it, 90 minus theta, which quadrant is this? First quadrant. 90 minus theta is first quadrant, right? So that's why all is positive, so that's why you have plus cos theta. If I write here plus, if I make this change, sine of 90 plus theta, sine of 90 plus theta, check here, sine at 90 will become cos, so cos theta. What are the sign of this? What about the plus or minus sign? Sign, which look at the operating ratio. Look at the operating ratio. Operating ratio is what? Sine. Which quadrant is this angle in? Second quadrant. Second quadrant, this value is what? Positive. Hence the answer will be positive. Okay. But if I change that, if I write here cos of 90 plus theta, cos of 90 plus theta, then something will change. At cos 90 it will become sine. So sine theta. Cos, operating ratio is cos. Check, this is the which quadrant? Second quadrant. Cos is what? So except for sine and cosec, rest all is positive, so negative. So will become what? Minus sine. So if you have sine 90 plus theta, it is plus cos, cos 90 plus theta is minus sine. I know it is very much basic, you must have learnt it already in your PU1, but if somebody has forgotten, I wanted to revise that anyway. Okay, is this clear? Very much clear. Quadrant rule, complementary function identities and Pythagorean identities. Moving on, even odd identities. Okay, for even and odd function, sine of minus theta is simply minus sine theta, cos of minus theta is cos theta, tan of minus theta is minus tan theta, and cot of minus theta is minus cot theta. Okay, so even and odd function, here we have even function as cos, rest all is negative. Okay, angle of sum and difference, very important. Please download this PDF and follow the signs properly. Here we have plus first, here we have plus here. Here we have negative as minus sign. Basically we have 6 formulas over here. Okay, sin A plus B, sin A minus B. Check here, sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Okay, there are 2 formulas over here. Here also 2 formulas. Cos A plus B is cos A cos B minus sin A sin B. Please check. Here the upside is plus and here it is minus. Here the sign is minus, this is plus. Difference in the formulas. Okay, please cross check. Tan of A plus B, we have a formula, tan A plus tan B divided by 1 upon tan A tan B. This is tan A, very important, tan B divided by 1 minus tan A tan B. Okay, 1 minus tan A tan B. This is for this part. So basically you have 6 formulas over here. You have 6 formulas over here. Please check, 2 for each term. Then we have double angle formula for sine, cos and tan. Sine 2a is 2 sin A cos A, cos 2a is cos square A minus sin square A, also equals to 2 cos square A minus 1 and 1 minus 2 sin square A. Very useful these 2 parts. Okay, very very useful. Next we have tan 2a as 2 tan a. This can be same as this. Okay, these formulas are arrived from this only. So this you see a result of application of the angle of sum and difference. Basically replace a plus b as a plus a. Replace a plus b as a plus a. It will become sin 2a. That's how you get it. Sin 2a, cos 2a and tan 2a. Okay, very much simple. Next we have triple angle formula, sin 3a. In this case you are going to do what? Sin 2a plus a. So you have here 3 sin a minus 4 sin cube a. Cos 3a is 4 cos cube a minus 3 cos a actually, and we have tan cube as 3 tan a. This is very rarely used, but still please remember it. 3 tan a minus tan cube a upon 1 minus 3 tan square a. Okay, sin square a, again this is the same result. This formula is coming from here. Please check. Here sin square is nothing but cos 2a 1 minus cos 2a by 2. 1 minus cos 2a by 2. How do I do that, sir? Move the sin square 2a on this side, cos 2a on that side, it becomes 1 minus cos 2a. We have 2 in the coefficient of sin square, put it in the denominator, we get 1 minus cos 2a by 2. Same we have for cos square, will this become plus. Similarity is there. For minus we have sin, for plus we have cos square. Okay, and for tan square a we have what? 1 minus cos 2a upon 1 plus cos 2a. Very very important, these two formulas. Okay, very important. Please remember these formulas. It'll be, if you know the formulas, your question solving becomes very fast. But if you don't know the formulas, then you have to do the derivation of every formula over there, and then it will be very much challenging and time consuming. So please remember the formulas. Again, from product to sum, okay, or sum or difference. Here we have sum difference to product. Okay, so you can use either of them. I'll recommend you to remember this formula. Remember these ones. If you remember these ones, you can get this one very simple. Okay, sin a plus b is what? 2 sin of a plus b by 2 and cos of a minus b by 2. When you have plus sign over here, this becomes plus, this becomes minus. Have a look. Plus becomes plus over here in terms of sin and minus in terms of cos. Okay, again everywhere it is sum of the angle by 2, difference of the angle by 2. Same we have for cos a plus b and cos of a minus b also. Please remember these formulas, very very important. For cos a plus b it is 2 cos cos. For cos a minus b we have 2 sin sin. Okay, please check. Minus 2 sin a plus b by 2 and sin a minus b by 2. So both of these are sin only, right? Check. Again, these formulas are already given to you in NCERT textbook, but I am giving you anyway as a reference at one place for all the formulas in the syllabus of unit test maths. Okay, miscellaneous results we have, again I already given you this formula, pi minus 0. Please check, I think I gave you over here. Okay, yeah, 180 minus pi, this result. Okay, I will explain you over here as well. Check this, at 180 sine remains sine and 180 sine remains sine, no change. 180 minus theta, which, where is this angle? Second quadrant, sine becomes positive. Second quadrant, sine is positive. Cos 180 minus theta, cos becomes cos only, but the angle is in second quadrant, so that's why minus sign. Tan 180 minus theta, tan remains as tan, but the value is in second quadrant, the angle value, that's why it is minus tan theta. Okay, and please remember the values of sine, cos, tan at the special angles 0, 30, 45 and 90. You will do that, right? I hope you know that. You know, sine value going to be 0, 1, sorry, 0, 1 by 2, 1 by root 2, root 3 by 2, and then it goes to 1. Okay, 0, 1 by 2, root 3, oh sorry, 1 by root 2, they have root 3 by 2 and 90 is what? 1. That is for sine. Again you can find for cos also by reversing the values because they are complementary. You know that formula, right? You know how to find the special angles of all the ratios, sine, cos and tan. It is very much important. Moving on to next chapter, which is matrices. In matrices again, differences are very very important. Row matrix, a matrix with only one row, example 1 cross n, one row n column. Column matrix we have only one column, so this will be 1. The column value is 1. There can be any number of rows. Okay. Square matrix means same number of rows and columns, so n cross n or m cross m. Okay. Diagonal matrix means the elements in diagonal will be, again this is defined only for square matrix. Okay. Diagonal matrix is not defined for, okay, please check, only for square matrix it is defined. So in the square matrix, if the diagonal element is non-zero except for all that will be 0, means all non-diagonal element are 0, that's called diagonal matrix. Scalar means, so the diagonal element is same, it can be 3, 3, 3, 4, 4, 4, 1, 1, 1, that is called as a scalar matrix. So any diagonal matrix with what? With your diagonal element same is called as simply scalar matrix. Identity is going to be when the diagonal element is always 1. When the diagonal element is 1, that is called as identity matrix, we have 0 matrix where all the elements of the matrix is 0, and we have transpose of matrix. Simply take this Aij as Aji. Basically, if I have A12 as the element, no, that will become A21. That's called transpose of the matrix. So all the element will in the given matrix, no, has to be taken like that. A12, A21, A13, A31, A41, A42, like that. Okay, A23, A32. So all the element has to be taken in that format. Replace that. So A12 becomes equals to A21. Replace it, switch it. Okay. Symmetric matrix, when that is equal, when the transpose is equal to A, that's called a symmetric. Very important, very important. And skew symmetric, when transpose is equal to minus A. Okay, negative of the value. So basically A12 equals to minus A21. Got it? Some very important definitions, please go through this. Let's move on. Now we have operations of the matrices. We have started from addition, subtraction. Okay, you have to add what? Corresponding elements. Corresponding elements you have to add, and when order is same, order is same, then only you can add. Okay, otherwise you can't add. So order is same, then only you can add, and also add only corresponding elements. Same goes in the difference also. Only defined if both matrices have the same order. I have already written that. Next is for scalar multiplication. You can multiply the number constant. If you are asked to multiply a constant to the matrix, multiply that constant to every element. Okay, multiply that constant to every element Aij. Aij represents your element. Okay, matrix multiplication, you have to go like this, rows to column. Defined only when the number of column in the first matrix, so basically here number of column is n, should be equal to number of rows in the second matrix. So see here, n, they are equal, no? This is n, this is n. Number of rows in the first matrix is equal to number of column in the second matrix. Here we have n, here we have also n. You can multiply now. And how do you multiply? Always row to column. Always row to column. Row of the first matrix to the row of the, column of the first matrix, row of first matrix to column of the second matrix. That will give me one element, okay, of the resulting matrix. Moving on, properties. The product of matrices is associative in nature. You can multiply them like this, AB into C or A into B plus C, B into C. That is true. Even if it is true for distributive property, you can multiply A with B plus C, written as AB plus AC. You can multiply a constant K with that also, but not commutative. Not commutative, because this is true only in the case of inverse. Only true for inverse. Only true for inverse. Means if A is inverse of B or B is inverse of A, then only we can say it is going to be commutative. Otherwise it will not be generally commutative in nature. Okay, you have to cross check that. If it is commutative means it will become what? Inverse or invertible matrix. Properties of transpose, please remember this, I have listed all the properties over here. A transpose is going to be A plus B transpose is going to be simply A transpose plus B transpose, but in the case of product it will reverse. Here we have AB, it will become BA. Okay, even if you have, let's say, A, B, C, it will become C first, B as it is, and then A over here. It will reverse, the order reverses, okay, in the case of transpose if it is multiplied. If it's a constant K, you can take the constant outside and take the transpose on the simply matrix A. Okay, moving on. Determinants. Now we are on to our second last chapter, which is determinant. Again, how do you find that? From 2 cross 2 matrix, multiply A and D. Subtraction, basically what method is this? Cross multiplication. AD minus BC. AD minus BC. For 3 cross 3 matrix, you can find across any row or column. You can use the first row, second row or third row, or you can use any of the column also. But use any one. Don't use all the 6. Use any one row or any one column. The result will be always same for all the 6 iterations. Okay. This time I'm using the first row. So you're going to take what? A as it is and multiply EI and minus HF. Remember. So you're going to do again cross multiplication for the second order matrix. When you're talking about the element A, remove the row and column where it is contained. Okay. And EI, you're going to simply do the cross multiplication. EI minus HF or FH. Same way you're going to move to B. You're going to move to B this time. Okay. And then you move to B, what will happen? You're going to remove the B second column and first row. So you'll have what? DI minus GF. DI minus FG or GF. And understand this, there's a sign order for all the determinant. What is it? First is plus, minus, plus. We have minus, plus, minus, plus, minus, plus. And how do you get this sign? based upon the address of this element. Remember, so you'll have this as A11, A12, A13, okay, A21, A22, A23, and then we have A31, A32 and A33. So wherever the sum of this number is even, that will be positive element. 1 plus 1 is even, 1 plus 2 is odd, 1 plus 3 is even, that's why plus minus plus. 2 plus 1 is odd, so minus. 2 plus 2 is 4, so even, so plus. Okay, so I hope you get it, how we are doing it. So wherever the sum of this, the I plus j value is even, that coefficient becomes positive. That's why here that is plus a, this is plus c. Whereas in the case of b it is 1 plus 2, so becomes 3 odd. That's why we have minus b sign over here. So that's how you expand any 3 cross 3 matrix to find the determinant value. Okay, please check. Now this value minus 1, I plus j represents the coefficient. If you combine that with mij, if you combine this sign with this sign, becomes your cofactor. These two combination. I'm talking about this minus 1 power I plus j times mij. This becomes your cofactor. Cofactor of that particular element. Which element? This element aij. So basically, if you multiply the element aij with the cofactor aij, okay, and take the sum across the same row or column, that's your answer for determinant. That's your answer for determinant of a matrix, let's say A. Summation of all the elements and its corresponding cofactor in the same row or same column. Then what will happen? You get the determinant value. Okay, the cofactor can be written as aij or cij. If you want, I can write this as cij. 1 second. You may write the cofactor as cij, but usually in NCERT they use aij. Okay, that's why I wrote. But just for your information, I can write cij as cofactor. Cij represents cofactor. Okay, and aij represents your element. Aij is element. I can change that. 1 second. Yeah. Now why I am giving you this information? Because it can be useful in the MCQs sometimes. Okay, so please remember this. Determinant is given by aij, basically element of the given particular row with the corresponding cofactor for all the elements of that row or any column you are taking per se. Okay, but if you take like ulta, if you take, let's say, element of the first row with cofactor of the second row, answer will be 0. Okay, if you take the product of this with any other element or element of any other row or column, then this will become 0. But if you take the same rows, element and cofactors and their product, you're gonna get what? You're gonna get simply value as your determinant. Please check. This is the element aij, and this represents your, let's say, I can write this in the with the help of letters also properly. 1 second. This represents your A11 and this is your C11. Okay, this represents your A12 and this is C12. Okay, again it will be what? A13 and C13. So if you add these now, if you add these, you're gonna get what? Determinant value. You're gonna get what? Determinant value. Got it? This is clear. Let's move on. Mij represents minor. Okay, Mij represents minor. Again, some properties of determinant. Please remember this, very important. Determinant of transpose remains same whether you take for determinant of transpose or the number of the matrix itself, does not matter. In case of determinant, transpose or the matrix will have same value. Okay, determinant of a product, you go here, determinant of A times of. So if you have multiplied 2, 3, 5 determinant, doesn't matter. Determinant can be separated individually for each of the matrices. Okay, for entity matrix it is always 1. For triangular matrix, if you have triangular matrix, determinant becomes product of the elements A11, A22, ANN, like that. Okay, for inverse matrix it's going to be what? 1 by determinant of A. Very important property, very much important. For inverse it's going to be what? 1 by determinant of A. 1 by determinant of A. Okay, effect of row and column swaps, no changes. Okay, the sign of the change, okay, fine. Effect of okay, the sign change for the determinant, nothing else. The value will remain same. Okay, that's why I said no changes. Effect of the multiplying a row by a scalar value, here we go. If a row is multiplied by k, the determinant will be multiplied by k. and if the two row or column are identical, determinant becomes equal to 0. Again, very important, very much important property. And if row or column are multiple of each other, means basically let's say one of the row is 1, 2, 3, other row is 2, 4 and 6. I'm saying that if one row is 1, 2, 3, other is 2, 4 and 6, isn't the multiple here 1 to the 2, 2 to the 4 and 3 to the 6? If it is the multiple of another, what will happen? Simply the determinant will become equal to 0. If you have two rows like this, either equal or multiple, determinant will be coming out as 0. Okay, done. So properties are very important. Please download the class notes and go through this. Okay, this is to find inverse. Ax equals to b. X is given by a inverse b. X is given by a inverse b. And how do you find inverse? Inverse is found by this formula, adjoint by determinant. Okay, adjoint of a by determinant. And how do you find adjoint? Adjoint, I've given you tricks. If you attended my previous session where I've solved the question, I've given you tricks to find adjoint for a 3x3 and a 2x2 matrix. Please go ahead and learn that. Okay, adjoint is basically your matrix of cofactors. Matrix of cofactors, so Cij taken as transpose. So you're going to find the matrix of cofactors, you're going to find the matrix of cofactors Cij and take transpose on that. That will be adjoint of A. Divide by determinant of A will give you simply inverse of A. Okay, and one more thing, you have to check this is true or not. If it is non-zero, then only inverse exists. If it is non-zero, then only inverse exists. If it is equal to 0, if the determinant value of any given matrix is equal to 0, then inverse will not exist. You can't find inverse in that case. Okay, and this is it. This is your cofactors formula. I wrote that already. Cij is taken over here in the variable, but usually you can also use Aij also. Aij also or Cij, your choice. Okay, I've written that cofactor matrix transpose. Okay, so all of that is mentioned. Now the last chapter which is to be discussed is continuity and differentiability. Continuity and differentiability. So when can you say, this is again definition of continuity. This is the definition part. When can you say a given function is continuous? So find the limit of the function and put that equal to function value. If you can find the limit that is equal to function value at that point. So limit at the point, let's say x equals to or x tends to a equal to f of a, then you're going to say the given function is continuous at that point a. And how do you find limit? Find the LHL, find the RHL, put it equal to each other. So limit are equal means what happens is, this means that these 2 points means that limit exists. Limit exists, excuse me, and is equal to f of a. Same thing I've written over here. Okay, so find LHL and RHL, check whether the limit exists or not. Once you get the limit exists, put it equal to f of a. Not in all questions you have to find that LHL RHL. Not in all the questions you have to find LHL RHL, because it will not be that kind of question. Might be a simpler problem. Simply find, you can directly use the limit formula. Okay, so use the limit value, substitute the value of x tends to a, and you get the answers. Different formulas are there. The different formulas, right, for different functions. I've given the formulas to you in my bridge course, so I hope you watched that. If not, go and learn from there, or you can use any of the textbook for the formulas or the reference of standard limits. Okay, so you're gonna use that and get the result for the limit value. If that is existing in nature and that is equals to f of a, you'll call what? You'll call function is continuous at the point a. Okay, LHL, RHL and function value at a mentioned over here. Next is what? Types of discontinuity. We have removable discontinuity. Whenever the limit exists or fa is not defined or fa is not equal to limit, then what happens is you're going to define the fa again, you're going to define the function again. So basically what happens, so limit exists in nature, but your fa value might be different or not existing in nature or not defined only at that point of time. Then what you're going to do, define the function again, and then the function becomes, this time continuity is validated. So we get call this to be as removable discontinuity. But whenever you have limit not equal, whenever there is a problem with limit, if there is a problem with limit, okay, then that becomes non-removable types of discontinuity. These two are non-removable type of discontinuity. Okay, so one of this is called as jump discontinuity when the limit is not equal. When the LHL and RHL are not equal, that is called a jump discontinuity. And when the function tends to infinity at any point of that point is called as infinite discontinuity. Okay, can we move on now? Okay, that is not that much relevant in your syllabus, but still I have given you for the sake of all the formulas. This is called as first principle of the derivative. Actually, this is in this case as RHD. They have given this as RHD. F of a plus h minus f of a divided by h is nothing but your right hand derivative. Okay, right hand derivative. All right. So please check. When can you say that given function is actually differentiable? Again, this is the definition of differentiability. When can you say that? Whenever you have LHD and RHD equal. Whenever you have LHD and RHD equal. LHD means left hand derivative, RHD means right hand derivative. So whenever that is equal, you can say that given function is differentiable. Okay. Now for non-differentiable, how to identify non-differentiable points? How to identify non-differentiable points? So we have, if it is discontinuous. If the given function is given as discontinuous, you're going to call this function to be non-differentiable. So that's very simple. If the function is not continuous, it cannot be differentiable. Moving on. If it has sharp corners, for example, modulus functions, sharp corners, non-differentiable. Okay, it has to have always smooth curves. That's your differentiable functions. Cusps. Okay, like this. There's a break in the function x power 2 by 3. Okay, it will be called as non-differentiable. Vertical tangents. Vertical tangent is again non-differentiable. These are the cases of identifying non-differentiable points. Okay. Now derivative formulas, where the questions will come from for the various functions, whether it is a constant, it is 0, for x it is 1, for x power n it is n times of x power n minus 1. Okay. If you had a constant multiplied over here a, you're going to keep the a outside. For sin it is cos, for cos it is minus sin. All the formulas are given over here. I've tried to explain many of them, but not required. You can just simply download this and get the understanding. I've tried to explain almost all the formulas that is listed over here, but still you need to put some effort and download this session's PDF and learn from it. Okay. If you have some doubt, let me know. Understand this very clearly. All your concerns, all your doubt, if you give me in this comment section, I'll take those concerns, I'll take those doubts and come to the live session and explain all of that to you. I'll clear your concepts, I'll clear your doubts. So it's very good that I'm coming for a live session. If you give me your queries, if you give me your concerns, I can help you out with that. Okay, so leave that every query that you have for maths in the comment section of this video or the previous unit test video where I solved the question. I'm going to take those doubts and do a live session on that. Okay. Now derivatives of logarithmic and exponential function we have. E power x is simply e power x. A power x becomes a power x ln a. A power x ln a. Again for ln x it is simply 1 by x. For log x it is going to be 1 by x ln a. So log x is going to be 1 by x ln a. What is the a over here? The base of log. Here again base of exponent. Okay. For inverse, again I have given you some formulas for sine inverse, for cos inverse. Okay, it's the same. There's only introduction of a minus sign over here. Please check. Okay. Again for tan inverse and cot inverse is the same. Only difference of minus sign. Same goes in the case of cosec and sec also. This is very rarely used. These four are used most of the cases. Clear? Let's move on now. Derivative rules. Sum rule. This is very simple, right? If you are asked to differentiate sum of two functions, simply differentiate the functions individually and then take the sum. Same goes in the case of difference also. Okay. Product rule. You have to differentiate one function at a time. For example, I can take three functions, f, g, and let's say k. Derivatives. All three are function only. Okay. You have to differentiate f, keep g and k as it is. Differentiate g, keep f and k as it is. This time differentiate k and keep f and g as it is. Okay, they have given four functions. Do the same thing. So differentiate one function at a time, and other three you can keep constant, or as it is basically. Okay. Now quotient rule. There's a difference in the quotient rule. This is very, very important. That's where you'll make mistakes. That's where you'll all make mistakes. Okay, even though it's very simple. So you have to identify the function in numerator and denominator. First job is to identify the function in numerator and denominator separately. First you're going to differentiate the numerator function. Okay, so check here, f dash you are finding, g as it is, minus sign comes, f as it is, g dash. This has to be the order. Differentiate the numerator function first, keep the denominator function as it is, minus sign has to be there. Differentiate the denominator function as over here, and keep the numerator function as it is, divided by denominator square. Okay. Now the chain rule. If we have functions here f, g and x, differentiate f first, then g, differentiate f first, then g, then comes x. Okay, x derivative is 1, that's why it's not written over here. Okay, second derivative is what? Derivative of first derivative. Second derivative is derivative of first derivative. Okay, this is the formulas, and that is the end of the session today. So I have tried to give you all the formulas for the chapters coming in your syllabus of unit test. If I have missed anything, you have to let me know that in the comment section. If you want something else from me, you have to let me know in the comment section. So this is the only way to talk between you and me. So give me your feedbacks, give me your understanding, give me your concerns in the comment section so that I can get back to you with a resolution of that. So that's it for today. I'm going to see you again very soon. Till then, take care. Bye-bye.